Hello, my friends of Hatari Labs. Welcome to this tutorial. This tutorial is about the tree or crop counting and classification with Python and Scikit-Learn. Okay. The history of this tutorial is that we try to do a tree counting, or a crop counting with GIS, and we didn't found some good plugins, or we couldn't make it in GIS. Yep. So then we started looking at some libraries like as OpenCV, but then again we tried to do this tutorial in Windows, so OpenCV is not so easy to install in Windows. And then we shifted to Scikit-Learn. Scikit-Learn is a library developed on, I think, let me check if Scikit-Learn is a library that actually belongs to the, where is it belongs to, is, well, it's I think it belongs to SciPy, but I'm not really sure. Well, it's an excellent tool, and Scikit-Image is an excellent tool, and is open source as well. And the use of Scikit is really it's a library purely in Python, so there is it's more simple to use, and it comes already installed in Anaconda. So if you download Anaconda, it comes with the Scikit-Image, so you don't have to do anything else. Okay, right. So let's do the tutorial. Okay, you will, on the description of this video, you will find the single crop and the multiple sizes. Okay, those are two crops, the two IPython notebooks. Okay, and then you will find a raster where you have olive tree farm. Yeah. So I'd rather open with paint. Okay, this is the olive tree farm, and then the tutorial will be to understand how many trees are there in this image. Yeah. Something that arouses here is that the trees are not from the same type and from the same size, because we have bigger trees and smaller trees, and there is something here that is the shadow. There is a shadow here that as well creates make it more difficult to understand the tree size. Okay, but however, the results were good, even though, and there is some empty places, or there are places where there are no trees. Okay, so then I'm going to close this. Okay, and then we have some, okay, here we have a small tree, a medium tree, a large tree, and an extra tree. Yeah, because this was mostly a subjective classification on the type of trees that we have here, and then we will discuss if the algorithm was able to interpret and to define these trees. Okay, so first of all, you can open your Jupyter notebook. Okay, so you just go here, and then you type Jupyter notebook. Okay, you wait till the kernel starts. Okay, the kernel has already started. Okay, and then if you want to increase your chances that you run this correctly, please on documents, make a folder that is called tutorial cuantificación de implementaciones. Yep, it's up to you. And then you will find here the tutorial. You put here the tutorial. Yep. And then you will find the two notebooks. First, we are going to do the single crop, and then we are going to do the multiple sizes. Okay. So on single crop, we are going first to interpret which are the trees that are classified as small. Okay. Okay, so this is small because this will be what this will do. It will look for this image in it will look for this template here in this image, and it will give you the best result and as well the most, I mean, the most relevant results. Okay. Okay, so great. So oops. Okay, then I run this. Yep. What does it what it does is that opens the total image and the template. Okay. Okay, I don't. Oh, kernel starting. Sorry. Okay, cool. Then it will show you the template tree. It's called árbol tree in Spanish. Okay, and this code that is actually comes is really similar to the code of the computation of scikit-learn. It will give you this line mostly is the one that runs the template matching, and this one is the one that give you the best result. Okay, this classifies it makes a tree graphic. I mean, it's a subplot in Matplotlib. This one give you, which is a template. This one give you the original image, and this one give you the results with a special circle where the template is found. I mean, we have told you that this is a part of this image. So actually, it will give you where in this image is this photo. Okay, so I just run it. Remember that in Anaconda, if you type Shift Enter, it's the same as type this one, as type this key. Okay, so this is the template, this is the image, and this is where this template is in this image. Please remember that we are dealing with one band of the image. So actually, we're not dealing with the 3 bands. So actually, in this case, we are dealing with the green color. Okay. Okay, because band 0 is the red color, band 1 is the green color, band 2 is the blue color, and band 3 is the transparency. Okay, so we are dealing just with the what we are doing here is we are dealing with the green band. Okay, cool. You can do this with the red band. If you want to do it with the red band, you just need to type this to 0. But in our case, we will do like this. Okay, so this is the template. This is where this template is located in the image, and this is the occurrence factor. So this is the probability that a pixel is related to this template. Okay, so but however, we will have a closer look of this image. So we run this. Okay, and then we run twice because I don't know why if you run twice. Okay, don't worry. Yep. So we run and then we find this is the pixel distribution where as greener, no, where as more the yellow value indicates that there is more the factor of occurrence is bigger. Okay. Then we filter to results to match similar trees. So we are going to have a threshold of 85. So all the values that have more than 85 will be selected as crop of this type. Okay. And then there is some spatial management of because this is not spatial. I wanted to do something in GIS because in the end you can import this into GIS and do this spatial, but However, for now, I prefer to explain this concept in only in Python. So there is some things related to Python, and here let's show the results. Okay, let me show. Let me run in again. Why I run again? Just for the image size. So this code actually gives you the what this code does is actually identifies all the images that are related to the template that we gave. So all these red dots will be related to the small olive tree. Okay, and this fill this solid dot here is also as well. This is where the template is found on the entire image. Okay, you can run this like, for example, as medium. Okay, and then kernel and run on. Once again, I will interpret all the places where there are medium crops. Okay, cool. And then we can do this as well as large with the large size. And then kernel start and run on. And then I run once again the last one. Yes. Okay, and these are the large ones, and this is the template. And then as well, and as an extra, because there is some extra large, and run on. Okay, and these are the extra large. Okay, cool. However, we have seen that there are different sets for every trim size. Okay, but in the next notebook, in this notebook, we are going to see how are the multiple sizes classification, and if they fit very well, and if they fit for the whole trees that we have on the photo. Okay, so first of all, let me this is in small just to bring it to the beginning. Kernel, start and clear output, just to drop it as the original. Okay, and then on multiple sizes, here we open the total image and the 4 templates of small, medium, large, and extra. And here we work with just one band. As you remember, we are only working with the green band. Okay, here we create a plot. So, okay, I run this and I run this. AX4. Tiene razón. Okay. It's right. I have to. Okay. Okay, yeah, that's right. Okay, let me fix this because, yeah. Okay, great. So here we have the small. If you see the small, because the smaller the tree have fewer pixels. The medium have more pixels. I mean, has a wider dimension in pixels. Yeah, and as well the extra also has a wider dimension in pixels. Okay, So here we see this is our 4 templates. Okay, cool. Then we create a result for every tree type. Okay, so if you find this, we are going to have a result for every tree type. And then in order to increase the performance of the plotting, yeah, I create a function here. I just run here. And then this is the plot that will show you the whole classification. I run this. And then I run it again just to update the size. And I don't know why. Let me put 11. And this is something about Jupyter Notebook. Let me put 8, 8. I don't know why it makes this. It's kind of annoying because sometimes it works, sometimes it don't. It doesn't. Well, I really assure you that it has not happened before. Okay, but here what you see is that we have sorry, what happened? Okay, and what it does, okay, yeah, well, well, it's something about the resolution. It worked before. I don't know what is happening before, but it's not here in this image. What you see is that we have, for every size, we have classification. Okay, so here we have all small trees, the medium trees, the large trees, and there is a small number of trees that were not classified because actually the template has not fit the machine learning algorithm have not recognized this tree as any template that we have gave. Okay, and this is a discussion because I think that this technology is promising, but there is more to do especially on the resolution of the image. So if you increase the resolution of the image, okay, and then if you make that the image, it will be exactly at noon, I mean at the hour with less shadow, you will increase better the results of the results of this exercise will be better. Just remember that as long as you have a image with more resolution, you will have as well the time of processing will be larger as well. So please take that into account, because this image is small, the template is small, and there is no problem with the timing. But if you have an image from a drone survey, the processing time will be much larger. Okay, so far from this, and I hope that you have enjoyed this tutorial. What we are Hatari Labs. Hatari Labs is a blog dedicated to numerical modeling and GIS. Okay, we have a Facebook account, we have a Twitter account, and then we have a newsletter. And if you like what you have seen here, and please subscribe to our YouTube channel and give it a like to this video. My name is Saúl Monfrontoya from Hatari Labs. It was a pleasure to give you this interesting tutorial. Remember that all the files from this tutorial will be located on the description of this video. I hope to see you in coming tutorials, and see you. Have a great day. Okay, see you. Bye-bye. Bye.